On a clear night, you can see it with nothing more than your naked eye. A bright, white scar cutting across the southern face of the moon, rays of shattered rock radiating outward like cracks in glass, stretching more than 1,000 kilometers in every direction, visible from 384,000 kilometers away. That is not a reflection. That is not an optical artifact. That is the aftermath of one of the most violent events in the inner solar system's recent geological history. And it happened at a moment in time close enough to Earth's own story that the creatures alive on this planet may have watched it unfold with their own eyes. That scar is called Tycho Crater. It is 85 kilometers wide, nearly 5 kilometers deep, and 4 centuries into scientific study, it is still holding secrets. This is the full story: the impact, the evidence, the debris that may have reached Earth, and the mystery that has outlasted every mission sent to solve it. The moon is covered in craters. Billions of years of bombardment have left its surface battered beyond count. But Tycho stands apart. At 85 kilometers across and nearly 5 kilometers deep, it sits in the lunar southern highlands with rays of ejected rock stretching more than 1,500 kilometers in every direction. On a full moon, those rays are visible to the naked eye from Earth. What makes Tycho remarkable is not its size. It is how fresh it looks. On a moon where most craters are 3 or 4 billion years old, worn to shallow shadows by micrometeorite erosion and solar radiation, Tycho's walls are still sharp, its rays still bright, its floor still well-defined. In lunar geology, that freshness carries a specific implication. This crater may have formed while complex life was already established on Earth, and that changes what it means to study it. When a small rock hits the moon, it leaves a simple bowl-shaped scar. Scale the energy up far enough, and the physics changes entirely. Tycho is a complex impact crater, and the distinction matters. The incoming asteroid struck at tens of thousands of kilometers per hour. In the first milliseconds, both the impactor and the rock beneath it were vaporized. A shock wave expanded outward, and the ground, briefly behaving like a liquid, collapsed inward. Then the compressed rock rebounded. Material from kilometers beneath the lunar crust was driven upward toward the sky. That rebound is preserved today as a mountain rising 2 kilometers above Tycho's floor. It is not volcanic. It is rock forced up from the moon's deep interior by the violence of the collision itself. Scientists recognize it for what it is: a core sample without a drill. The moon's interior, exposed and waiting, accessible to whatever mission reaches it first. Every impact leaves evidence. Tycho left a great deal of it, and scientists have spent years decoding what that evidence reveals. The ejecta rays visible from Earth are not randomly scattered debris. They are organized. Based on the asymmetric distribution of those rays, researchers have determined the asteroid struck at an oblique angle of roughly 35 to 45 degrees. The crime scene, read carefully, tells us not just that something hit, but exactly how it hit. Across Tycho's floor, smooth, flat regions mark where molten rock flooded the crater and then cooled into glass-smooth sheets. These are geological photographs, frozen the instant the violence ended. Their chemistry provides direct evidence of the impactor itself. And then there is the evidence found 2,000 kilometers away. Samples returned by Apollo 17 contain material consistent with Tycho ejecta, meaning the collision sent debris across a quarter of the visible lunar surface. More than that, seismic energy from the impact likely triggered a massive landslide at the Apollo 17 landing site. The ground carried the force of the collision outward like a shockwave through stone, thousands of kilometers from the point of impact. The Tycho impact released energy equivalent to approximately 30 trillion tons of TNT. The most powerful nuclear weapon ever detonated released 50 million tons. The scale difference is not a matter of degree. It is a difference so vast the comparison barely provides orientation. The asteroid was vaporized on contact. A fireball expanded at hypersonic speed. A shock wave fractured the crust in all directions. And then, as the chaos subsided, billions of tons of debris began raining back across the lunar surface, except for the material moving fast enough to escape. The moon's escape velocity is only about 2.4 kilometers per second. An event of this scale launched enormous quantities of rock well past that threshold. Those fragments entered independent orbits around the Sun, and in the inner solar system, one gravitational body intercepts passing debris with particular efficiency: Earth. Lunar meteorites reach Earth regularly. Hundreds have been found embedded in ancient rock and Antarctic ice. The mechanism is understood. A major impact launches material at escape velocity. That material enters solar orbit, and some portion eventually intersects Earth's path. The delivery of Tycho rock to Earth is not speculative. Given the physics, it is essentially inevitable. The only question is how much and when. If the commonly accepted age of approximately 108 million years is correct, the answer lands during the Cretaceous period. Dinosaurs moved across every continent. The Atlantic was still young, and on the night side of Earth, the Tycho impact would have appeared as a sudden, brilliant flash on the moon, something no creature on Earth had ever seen. In the days and weeks that followed, fragments entered the atmosphere as streaks of fire and struck the ground across a wide zone. Not a mass extinction, but a delivery of the moon to Earth's surface, in pieces, while the dinosaurs were watching. Here is where Tycho's story stops being tidy. Because the 108 million year estimate is not universally accepted, and the problem is the missing evidence on Earth. The age comes from Apollo samples. Scientists identified rock material believed to be connected to the Tycho event and dated it radiometrically. The result was approximately 108 million years ago. That number entered the literature, got repeated, and became the canonical figure. But an impact of that scale, at that age, should have left a detectable signature in Earth's sedimentary record, a global layer of extraterrestrial material, a spike in isotopic markers from the mid-Cretaceous. So far, that signature has not been convincingly found. Some researchers argue the terrestrial evidence is simply waiting to be located. Others suggest the crater may be significantly older than assumed, placing the impact in an era where Earthside traces would be even harder to identify. As of today, Tycho's true age remains genuinely unresolved. Decades of study, returned samples, sub-meter orbital imagery, and we still do not know with certainty when one of the most visible features in the solar system was created. It would be easy to look at Tycho and see a frozen relic, violence preserved in vacuum, unchanging. But in 2024, astronomers confirmed a fresh impact crater newly formed on the lunar surface, captured in real time by orbital cameras. The process that created Tycho is ongoing. The same debris field responsible for that collision is still out there, cycling through the inner solar system. The moon is still accumulating scars. Tycho is not history. It is one entry in a record that is still being written. Future lunar missions are in active development, and within the planetary science community, Tycho is already being discussed as a target. A crewed or robotic mission to its central peak would be a scientific event. Rock from that mountain, forced up from the moon's deep interior by the impact, would answer questions about lunar composition that orbital study cannot resolve. Samples from the melt pools would date the impact with a precision that indirect Apollo-era evidence never could. The age debate would finally be settled. Tycho Crater is 85 kilometers of open questions, studied for 4 centuries, photographed by every lunar orbiter ever launched, and still not fully understood. The most important answers may be locked inside the central peak, waiting for the first geologist who makes the journey. The moon kept its secret for millions of years. It will not keep it forever. One of the most visible features in the solar system, 4 centuries of study, physical samples returned from the lunar surface, and we still do not know with certainty when Tycho Crater formed. So here is what I want you to answer. Do you think the 108 million year age holds up? Or does the missing Earth-side evidence mean the real number is something older? Drop your take in the comments. I read every single one, and there is always a real debate down there worth joining. If this is the kind of science storytelling you come here for, subscribe and hit the bell. Every video on this channel is built the same way. Research first, no shortcuts. The next one is already in production. Do not miss it.